Following construction of a frequency distribution and graphing a frequency distribution, we can also start to describe it using terms that are in the statistician's toolbox, so to speak, words that we use to describe certain things. So let's start with an example. This is the graph of the cigarettes per day from the smoking study that we've constructed in an earlier video, and then we graphed it. We can start to characterize or describe this particular distribution. We characterize it in terms of its shape, its central tendency, and its variability. We're going to talk about central tendency and variability later, but today what I'm going to talk about is symmetry, skew, and modality. Symmetry refers to the possibility or the fact that one half of the distribution looks like a mirror image of the other half. If that is true, we call the distribution symmetrical. So this red distribution, for example, if this were a frequency distribution, if we divided it in half along a vertical axis here, if we drew a vertical line, if this half is the mirror image of this half, we call that distribution symmetrical. The blue distribution is symmetrical. The light blue distribution is symmetrical. This green distribution is symmetrical. That's one of the ways that we describe distributions. We call them symmetrical or asymmetrical. Another way we describe frequency and relative frequency distributions is in terms of skew. Okay, and skew is a technical term here. I know that we all often use the term skew like his point of view was skewed, or you know, you can skew somebody this way or that way. But in statistics, it actually refers to a technical aspect of the data. So positive skew is when we have high frequencies of low values, and negative skew is when we have low frequencies of low values, and the opposite. So if we have high frequencies of low values and low frequencies of high values, we say that the distribution has a positive skew. If we have low frequencies of, would be low frequencies of low values, but higher frequencies of high values, we would say that's a negatively skewed distribution. You just have to sort of memorize that a distribution that looks like this is positively skewed, a distribution that looks like this is negatively skewed. The way I remember it, positive and negative, is that if you were ever a kid, right, we're all kids, and if you ever rolled down a hill, right, a grassy hill, and had a lot of fun doing that, you know that as you go down the hill, you get faster and faster and faster. You positively get going, or you get faster and faster. I think of that as positive. So the way I remember this is if you're rolling down the hill, you're getting faster and faster and faster and faster. So this is the positively skewed distribution. As you're rolling down, you get faster. This distribution, you're rolling, but you're slowing down. This is the negatively skewed distribution. Maybe that's a stupid mnemonic, but it's the way I remember the difference between positive and negative skew. Modality refers to how many modes or how many humps it has. We have a unimodal distribution here. It has one hump. A bimodal distribution has two humps. And you can have multimodal distributions with many, but those are infrequent and uncommon and so on. So when we have a distribution like this that we've constructed, we can start to talk about it. We can say that this is an asymmetrical distribution. One half of the distribution is not the mirror image of the other. There's positive skew here. We have high frequencies of low values and low frequencies of high values. And it seems to be unimodal. We have one hump here. Now some people might say, well, that's also a mode. That's a hump, but it's really not a hump. It's you know, somewhat in line with the overall pattern here. So that's it on describing modality and skew and symmetry in your graphs. So we're going to now move on to the on-the-board exercises for constructing a frequency distribution. So take a look at that video when you get a chance.